I have here an oscilloscope, and that's what you're looking at. And before that, let me just show you what's going on. Right here, I have a Forester STi Cluster with an oscilloscope probe onto that chip right there, which is the motor driver for the tachometer and the speedometer motors. And how that works is the main controller, which is sitting underneath this guy right here, sends serial data onto that pin there, and that controller takes that serial data and controls the motors, makes them go up and down, stuff like that. And how that works is right here on this data sheet I have. Is an MLX10407, and it looks a little bit like this. So the way it works is that it has a serial clock right here, and it sends data on this pin right here. It will send a 1-bit start bit, the 10-bit angle identity. It will send the quadrant it wants to be in, and the quadrant is right here. So obviously gauges are a radial thing. The needle moves just like this. And so based on the quadrant it is in, it'll send a 0 or a 1 for which quadrant it wants to be in, along with the 10 bits for the angle. And those 10 bits are talked about right here. So the first bit, D1, must be a 1. That's the start bit, so that's when it knows when it starts receiving the data. D1, D2, D3 are instruction bits told to where to write the data. So this one would be for logo 1, which I believe is the tachometer. So after the start bit, the next bit would be a 0, the bit after that would be a 0, and the bit after that would be a 1 if you want to send data to the logo 1, which is the gauge 1. The next 10 bits, which are D4 through 13, set the angle value, where D4 is the most significant bit. And the last 2 bits represent the quadrant, which is what we just talked about. Okay, so this is our oscilloscope. As we see here, we see this line, a blip up, a blip down, blip up, blip down, and so on. The oscilloscope shows the waveform that is given off at a certain time interval, and right now I have the trigger auto selected. So right now, the oscilloscope is reading 0.2 volts for every one of these lines right here. And it's reading, is that 10 microseconds for every one of these lines right here. So if you can imagine, one of these is taking up half of this block right here. So if it's every 10 microseconds is one of these blocks, it takes half of that, that's a 5 microsecond pulse. And we can see here that there are multiple pulses. So every 0.5 microseconds there's going to be a pulse. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The rest of this doesn't really matter for us right now, but as you can see there are 14 pulses, which means that's 15 pulses, which means that's 16 bits of data. So the first bit, like we talked about, is right here. That's set to a 1, and it will always be set to a 1 because that is what tells the controller to start sending data. Here we have selected the speedometer, which I believe is logo 2. And so the second bit is a 0, which if we go right back over to our sheet here, we see writing request for logo 2. The second bit should be a 0. So now the next 2 we should expect to be each be 1s since we're writing to logo 2. We go over here to the next bit, which is a 1, so that would be correct. And we go over here to the next bit, and that's also a 1. Cool, so we know that we're writing to logo 2 with this configuration we have. So then if we go over here to the next bit, which is the fifth bit, D4, as we saw on the sheet, this is the actual angle that it's going to be set at. And so if I turn my knob to increase the frequency, which should increase the angle, we can see that the bits actually move over from least significant bit to most significant bit as the value increases. And you can see that the bits literally shift over. Alright, so let's go back to 0. So we know that the next 10 bits from D4 to D13 are angle values, so let's show you that. So that is D4, that's D5, and these are all zeros, D6, D7, D8, D9, which is a 1 in this case, but it's just not enough to move our gauge here, which I actually can't show you anyways. D10, D12, and D13 right here. So all of this data from here to here is the angle, and we can see that none of that past that changes, except for this, which we'll get to in a second, as we increase our frequency. So, very cool there. So now, this part right here was, if we go back to our sheet, D14 and D15, the quadrant, which again, if we go down here, is this. So as the needle increases, it obviously goes into this, starts in this quadrant, goes to that quadrant, goes to that quadrant, and goes to that quadrant. So as the speedo increases, the quadrant will be set to either these values right here, the 2 bits that control them. So when we start out, we should actually see a 0, I guess a 0, 0 for quadrant 4, a 0, 1 as we go into quadrant 2, a 1, 0 as we go into quadrant 3, although I already am talking about these backwards, and a 1, 1 as we go into this quadrant right here, which is quadrant 3. Back to the oscilloscope, we're starting at 0, which, sorry you guys can't see that, or you can't see the gauge because my gauge is actually broken, but so we're going to increase it, and we should see that bit go up. So boom, there we go. So we expect a 0, 1, so now we're in that quadrant 1. So you can imagine that to be reading about, if you look at this guy right here, be reading about right here. So we're in this quadrant right here, as opposed to this quadrant right here that we started in. So we're going to increase it some more. And there we go, it switches again. So notice right here, this bit went from a 0 to a 1, so that's the most significant bit for the quadrant selection. So if you can imagine it, we're right over here now. And keep increasing, and then boom, that most significant bit is kept as a 1, and the least significant bit swapped back over to a 1, so reading 1, 1, which means we should be reading about right here in that quadrant. And keep increasing it, and now we're maxed out on speed, and obviously the quadrant hasn't changed because it doesn't read data past that. So if we lower it again, we can see everything kind of change back down and fumble back in. And that's sort of how the speedometers kind of work in these Forester STi clusters. I'm not really sure what sort of insight that gives you, or if that made any sort of sense if you don't really know what an oscilloscope is, which probably should explain that too. But that's what I have for right now, and I think it's pretty darn cool that I can look at this right on my oscilloscope and see exactly what the cluster is doing based on the data sheet for the chip that controls it. That's all I have now, and I'll probably put a little bit about how the oscilloscope actually works in the start of the video so it actually makes sense.